Let's talk about when do we use the chi-square analysis. So if you notice, we didn't see that in the previous slide. The majority of our textbook is talking about the goodness of fit chi-square test, but we're not really going to be doing that particular test here. What you guys will be learning more so is the chi-square test of independence, which is a higher level statistical test when we're looking at chi-square analysis. I encourage you guys to read the little box on page 307 that talks about the difference between chi-square goodness of fit and chi-square test of independence. And so the one that we're going to be talking about, the test of independence, is really looking at and being able to answer the question is how related or unrelated or how independent are your IV and your DV to each other. And really we can really ask, are there significant differences between the groups when we're looking at the differences? So really when we're working with chi-square analysis, we're determining if what we observe in a distribution of frequencies is what we would expect by chance. So in this case, we're comparing two or more groups on some categorical variable. Whether one variable is nominal or the other variable is ordinal, or they're both ordinal or they're both nominal, we have categories for these. So here are a couple examples. Let's say we want to look at maybe some differences between men and women and whether or not men or women tend to be more obese or not. Right, so now we're looking at two nominal variables. Gender is nominal and obesity is nominal. But what about if we wanted to look at whether or not there was differences between grade levels and whether or not students tried alcohol? And you can see here we define our grade level as 9th, 10th, 11th, and 12th graders. Well, technically, yes, 9th, 10th, 11th, 12th graders, there is some hierarchy. So what level of measurement would you say we are? Or what level of measurement would you say grade is? Ordinal, right? We have some ranking, we have some hierarchy here. But while we could technically calculate an average grade level among our sample, we can't really look at differences if we calculate a mean. So in this case, we're going to treat an ordinal variable as categorical. And so much that we're going to say that we have 4 different groups for our independent variable, 9th, 10th, 11th, and 12th graders. And we want to see, is there a difference between these 4 groups on whether or not they've ever tried alcohol? Yes or no? So when it comes to doing a chi-square analysis, because we have the choice of using ordinal variables, we know that ordinal variables can be a little tricky. We can treat them 2 different ways. We can treat them qualitatively as a category with groups like we're doing here, or we can treat ordinal variables if they have 5 or more groups and it makes sense for us to calculate and interpret a mean and a standard deviation, well, we can do that as well. But if we're going to treat an ordinal variable as a quantitative variable where we calculate a mean and a standard deviation, we do not do a chi-square test of independence. We do not use chi-square analysis if any of our variables utilize a mean and a standard deviation. All we're doing with chi-square analysis with our variables is looking at frequencies, looking at the counts of what we're seeing for our responses. Okay, so one thing that we can use to really visually display the relationship between these 2 variables and really be able to see the differences between the 2 variables is by creating what's called a contingency table, also known as a cross-tabulation or crosstabs in SPSS, and we'll see that verbiage later on. So here we see we have gender and we have work status. Are you male or you're female? And do you work full-time or do you work part-time? And then we can see our sample size here, really just looking at how many males there are, how many full-time workers there are, and really you can then see how many female part-time workers there are, 3,717 female part-timers. So this is simply what we call a contingency table or crosstabs. So let's use this example here that we're going to use for our lecture. We want to look at maybe the relationship and the differences between occupation and political affiliation. So let's say we're looking at 3 groups of workers, teachers, salespeople, and farmers, and looking to see their political affiliation. So are you a Democrat? Do you identify as a Republican? Or do you identify as an independent? And we can see here the data for all of our teachers, salespeople, farmers, and for each of our political affiliations. And so each box is pretty much called a cell. And really what we're seeing in the orange is that this is the frequency, the count of the number of people that belong to that cell. So for example, how many Democratic teachers are there? Well, we see that we have 26 Democratic teachers. And so really, we see that we have 38 teachers, 32 salespeople, 30 farmers, and this is pretty much just all the way on the margin of the rows. And we can look at the very bottom row for the columns and see we have 46 Democrats, 38 Republicans, and 16 independents. And so if we were to add up all the occupations, we would see that that adds up to 100 people. And if you add up all of the political affiliation folks, we can see that also adds up to 100. So one of the things about contingency tables or crosstabs is that the margins will always add up to the very bottom corner, which is going to be your entire total sample size, which in this case is 100 people. So one thing you may see in terms of an example problem is something similar to this. I may give you a crosstabs. I'm going to have you complete the contingency table based upon what's given to you. So go ahead and pause the video and work through trying to fill out the rest of this contingency table. When you think you've got your answers and you've double checked all your calculations, go ahead and unpause the video. Alright, so let's see how you did. So here are the answers. Did you get the same numbers? Hopefully you did. So this is going to be an example of how you would complete a contingency table. An example of which you might see in, let's say, maybe your in-class exercises or homework 5, which you've probably seen already. But let's talk about probabilities. This is one powerful thing that we can do with contingency tables or crosstabs. So we have the formula here. P, which is the probability of whatever it is that we want to talk about or look at, is equal to n sub a of big N. So really when we think about what small n is and what big N is, you have to think about what is the question really asking about. So let's look at the first problem. What is the probability of being a teacher among the entire sample? So in this case, we want to know what's the probability of being a teacher. And then you have among the entire sample. So given that, what do you think is going to be your denominator and which one's going to be your numerator? Is it going to be teacher or is it going to be your entire sample? So your denominator is going to be your entire sample because this is what we want to look at among the entire sample. And when we're talking about the probability of being a teacher, well, how many teachers are there in our entire sample? There are 38. So we would set up our work to be that 38 over 100 equals 0.38. This is the probability of being a teacher among the entire sample of 100 people. So why don't you go ahead, pause the video, and try to work through these other two problems. If you get stuck, just try to work through them, see if you can figure it out, and then unpause the video and see if you got the right answers. Alright, so let's take a look at the second question. So among Republicans, how many Republicans are there? There are 38 Republicans. So what's the probability of being a teacher among Republicans? Well, we see that there are 38 Republicans, so that's out of the entire people that we're looking at. So that's going to be our denominator, our big N. But among Republicans, what's the probability of being a teacher? So how many Republican teachers are there? There are 10. So we set up our formula as the probability of being a Republican teacher is equal to 10 divided by 38 is equal to 0.26. This is the probability of being a teacher among Republicans. And the last question, what is the probability of being an independent if you are a farmer? So if you are a farmer, how many are there? There are 30 farmers, and we see that 10 of those 30 farmers are independents. So the probability of being an independent if you are a farmer is 10 out of 30, which is 0.33. So you want to think about among whom. What is the denominator? That's the group, the entire group that we're talking about. Sometimes that's the entire sample, and sometimes it's just one particular group, whether it's coming from your IV or from your DV. But you need to think about, okay, well then what's my numerator? That's the specific group, a specific characteristic or a specific combination sometimes, and that's going to be your numerator.